So let's just talk about the Prim's algorithm. So as we know, Prim's algorithm used to find the minimum spanning tree from a connected undirected weighted graph. So here you can see we have one connected, undirected and weighted graph. Now let's see how we can use the Prim's algorithm to find the minimum spanning tree. So here are the steps of the Prim's algorithm that we're gonna follow. So in Prim's algorithm, the first step is to remove all the loops and the parallel edges in our graph. So here you can see this is one self loop. So that means we have to remove that from our graph. So we do not care about the weight of the loop, we just have to remove that. And also we have to remove the parallel edges. So here you can see in between the node B and C we have two parallel edges. So among these two parallel edges we're going to keep the edge with the lowest weight. So here in this case we're gonna keep the edge 8 because it has the lowest weight. So that means we're gonna remove this edge with the weight 10. So we are done with the first step. Now next we have to choose any vertex as the starting point. So that means you can choose any arbitrary vertex as the starting point. So let's just start from this vertex A. Now the step 3 is to pick the smallest edge from the selected vertex. So from this vertex you can see we have two edges with the weight 2 and 5. So we're gonna choose the edge with the smaller weight. So that means in our minimum spanning tree we're gonna keep the edge with the weight 2, which leads to the vertex B. So the next step is to add the connected vertex to the minimum spanning tree. So you can see, so the vertex is added to our minimum spanning tree. Now we have to repeat the same process by selecting the minimum weight edge from all the edges incident to the minimum spanning tree. That means, so from this minimum spanning tree we're gonna compare all the edges connected to these vertices. So we're gonna compare their weight. So we're gonna compare between 8, 6, 3 and 5 and we're gonna choose the minimum weight edge. We're gonna choose the edge with the weight 3. So that means we're gonna choose this edge with the weight 3. Now this way we're gonna keep repeating this process and we're gonna stop when all the vertices are included in our minimum spanning tree. And the minimum spanning tree will have v-1 edges. So let's just repeat the process. So we have taken the vertices A, B and D and we have taken the edge between A and B and the edge between B and D. Now again we have to perform the same comparison with all the incident edges. So now we're gonna compare between 5, 7, 6 and 8 and we're gonna choose the edge with the smallest weight. So among them you can see 5 is the smallest. Now here the problem is if we take this edge with the weight 5, then here we're gonna have the cycle. So as we know in our spanning tree we should not have any cycle. So that means we cannot take this edge in our spanning tree. So that means we have to compare between 7, 6 and 8. So that means we're gonna choose this edge. So we're gonna choose this edge with the weight 6. So we have taken these three edges. So we're gonna follow the same process. That means again we're gonna compare between the edge 7, 4 and 8. So among them we're gonna choose this edge with the smallest weight. So here we're gonna choose the edge with the weight 4. Now again we're gonna compare all the incident edge weights. So this time we're gonna compare between 8, 1, 6 and 7. So among them 1 is the minimum. So that means we're gonna take this edge with the weight 1. So we have taken this edge. Now again we're gonna compare all the incident edges. So this time we're gonna compare between 8, 9, 6 and 7. So among them you can see 6 is the smallest. So that means we're gonna take the edge with the weight 6. So we're gonna take this edge with the weight 6. So according to this algorithm now we can stop this process because we have included all the vertices in our minimum spanning tree. So here we have a total of 7 vertices. Now here also you can see we have a total of 7 vertices. So we have total of 7 vertices. So that means in our minimum spanning tree, the edge count will be 7 minus 1, so it will be 6. So here we have 1, 2, 3, 4, 5 and 6 edges in our minimum spanning tree. So this way we can follow the Prim's algorithm steps and we can find the minimum spanning tree of one graph. So hope you understand the concept. See you in the next one. Take care.